All right, what's up, everybody? So this video is intended to take you through how to run the Goodness of Fit chi-square as well as the Test for Independence chi-square within SPSS. So the first thing that I want to draw your attention to is the fact that you need to remember that when we're working with a chi-square test, we're working with what's called a non-parametric test, which means that the variables that we choose for this need to be categorical variables. We are going to first be working through the goodness of fit test, and so with that we need to identify a nominal variable that we are first going to be conducting our frequency tables with before moving into the chi-square analysis itself. Now I want this that I'm demonstrating here on the screen within SPSS to match what's in the PowerPoint. And so to that end, I'm going to use the variable sex. Now, if hopefully you're watching this after you've already seen the presentation on chi-square, and within that I demonstrated how to write the results, reporting the results for the goodness of fit chi-square test. Now, like I said, the first thing that we want to do is run a frequency distribution so that we have a good sense of what's going on with the variable, ensuring that everything that is happening in our variable looks good for us. We're going to come down to analyze, or I'm sorry, select analyze, descriptive statistics, and then frequencies. And then we are going to take the sex variable, place it into the variable window by double clicking. You can click, drag and drop, or you can select it and then hit the arrow button that'll take it over to the right. Now we're going to select mean, median, mode, and standard deviation and variance. And that's in this statistics window. And some of you may be wondering to yourselves, hey, when it came to us thinking about some of our nominal variables, Michael, you said that we can't calculate an average for them, and you are absolutely right. So that is still the case here. I'm really doing it more as getting you in the habit of understanding that that's part of the process that I want you to keep in mind. We're going to see that by selecting the measures of central tendency as well as the measures of variability, that it's going to produce those values for us. However, they're not necessarily going to mean much to us in terms of our analysis. The one that will carry the most significance for us is going to be the mode, which will tell us which category was selected most often, which is still a measure of central tendency that we can use for a nominal variable or ordinal variable. But this one, the sex variable, is nominal. So after we've selected those, we're going to select OK. It produces this output. We have our statistics table. So we have 1,062 people as part of this analysis. We're missing 5 of them. And the most common selected category is a 2, which in this case aligns with the category of female. Now, looking at our frequency distribution, we see those patterns reflected. We have 453 males, 609 females, a total of 1,062 who were a part of this, but only 1,057 ultimately. Actually, I think yeah, we already took out the 5. So 1,062 who answered this question of what is your sex. Now, make sure that with your SPSS assignment, you are including both of these tables with with submitting your assignment. Now, in order to run a goodness of fit test, it's actually a not so intuitive process that you need to move through. So I encourage you to take it slow as you're watching through this video. Make sure you pause it as often as necessary, that you are able to note how it is that you go about running a goodness of fit test within SPSS. So in order to do this, we're going to come up to the Analyze button. We can stay in this window. We don't necessarily need to go back to the variable window. I know that several students have sent me questions asking where it is that we're getting this data. Please note that we're still using the 1K survey data. We have not switched to a different data set. So as long as you follow the original instructions on how to upload that data set to our, to your account really with the school, then you're good to go, right? You don't need to go through that process again. All right, so we'll come up to Analyze. We'll come down to Non-Parametric Tests. We're going to highlight legacy dialogues, and you'll see this pop up for chi-square. I'll hold here for just a moment just to ensure that you are able to identify the process, analyze non-parametric tests, legacy dialogues, chi-square. And again, what we're focusing on right now is the goodness of fit, or the one-way chi-square test. So we'll select chi-square. This will be our pop-up. Our test variable list is where we are going to be placing the variable that we are working with. So you can drag and drop, double click, use the arrow. We're going to select an additional option here. So you'll select the options button and you'll select descriptive. So this will ensure that when it runs a test, it's also going to give you the descriptive statistics for this analysis. We'll select continue. We don't adjust any of these other settings. We'll click OK. And here's our output. So these are the descriptive statistics. We have our N of 1062, our mean and standard deviation, but for this particular analysis, that doesn't carry any significance for us. So with this frequencies table here, under where it says sex is identifying which variable we are working with. Hopefully this looks familiar and that you've already made your way through the lecture. And so this variable is, we have 453 males in this sample, 609 females in this sample. We expected 531 males. We expected 531 females. And so recall that this residual column lets us know how far our observed frequency differs from the expected frequency. We have fewer males than we expected. We observed 453. We expected 531. That is a difference of 78. We observed 609 females. We expected 531. That is a difference of 78. Down here in your test statistics table, we have the chi-square statistic. We have our degrees of freedom and our significance. Recall that all these are a part of reporting your results. They all make their way into the, all the information that follows your chi-square symbol. Recall that your asymptotic significance is where you are going to find significance for your analysis. You are comparing to 0.05 as we have done up until now. And remember that relates, just to kind of call your attention, 0.05 has to do with our confidence level. Right? Working with 95% confidence. And so since this, our significance level for this analysis is less than 0.05, we did find significance. So as far as your null and research hypotheses, remember that we're talking about there is a significance between the observed frequency distribution and the expected frequency distribution, or there is not a significant difference between the observed frequency distribution and the expected frequency distribution. As a concluding statement, we would say, at least based on this analysis, because we have an that we have a significance level less than 0.05, we find that there is a significant difference between our observed frequency and our expected frequency for this variable of sex. Therefore, we reject the null hypothesis. So that's it with regard to being able to run a goodness of fit chi-square test.